It is generally recommended to install the buck-boost transformer as close to the alternating current unit as possible rather than at the electrical panel. The primary reason is to minimize voltage drop. The longer the wires between the transformer and the alternating current unit, the greater the voltage drop that will occur. This can reduce the voltage available to the alternating current unit, which can affect its performance and lifespan. Consider the following. Voltage drop is influenced by several factors, including the wire gauge, the length of the wire, and the current flowing through the wire. A longer wire run will inherently have a greater voltage drop for a given wire gauge and current. Installing the transformer closer to the load reduces the length of the wire run carrying the boosted voltage. This is important because alternating current units often have specific voltage requirements for optimal operation. Insufficient voltage can lead to reduced efficiency, overheating, and premature failure of the motor or compressor. Secondly, power loss is a crucial consideration. Installing the transformer at the panel will result in power loss due to the resistance of the wires. This can lead to increased energy consumption and higher electricity bills. The power loss in a conductor is proportional to the square of the current and the resistance of the conductor, often expressed as I squared R loss, where I is the current and R is the resistance. By placing the transformer closer to the alternating current unit, you reduce the current carrying distance through the wires, thereby minimizing these losses. This translates to a more efficient use of electrical energy and lower operating costs. Furthermore, consider safety. It is generally safer to have the transformer located near the alternating current unit, as it will reduce the risk of electrical shocks or fires. Keeping the high voltage connections closer to the load and within a controlled enclosure near the alternating current unit can improve overall safety. Running high voltage wiring over long distances increases the potential for insulation damage, accidental contact, and other hazards. Additionally, local electrical codes and regulations may have specific requirements for transformer installations, including proximity to the load, ventilation, and protection from environmental factors. Always consult with a qualified electrician and adhere to all applicable codes and standards. To elaborate on voltage drop, consider the formula for calculating voltage drop in a direct current circuit, which provides a fundamental understanding applicable to alternating current circuits as well. The voltage drop volt sub D equals 2 times K times I times D divided by circular mils, where K is the direct current resistance for 1000 circular mils foot of wire, which is typically 12.9 ohms for copper. I is the current in amps. D is the distance in feet and circular mils is the cross-sectional area of the wire in circular mils. This formula highlights the direct relationship between distance and voltage drop. While alternating current calculations are more complex due to impedance and power factor, the principle remains the same. Longer wire runs lead to greater voltage drop. Regarding power loss, remember that the power loss in a conductor is given by P equals I squared R, where P is the power loss in watts, I is the current in amps, and R is the resistance in ohms. The resistance of a wire is directly proportional to its length and inversely proportional to its cross-sectional area. Therefore, a longer wire will have a higher resistance, resulting in greater power loss for the same current. By minimizing the wire length between the transformer and the alternating current unit, you reduce the overall resistance of the circuit and minimize power loss. In terms of safety, proper grounding and overcurrent protection are essential for any electrical installation. Ensure that the transformer is properly grounded according to local electrical codes and that appropriate fuses or circuit breakers are installed to protect against overloads and short circuits. Regular inspections and maintenance can also help to identify and address any potential safety hazards before they become serious problems. Considering practical installation, when installing a buck-boost transformer, firstly, carefully assess the voltage requirements of the alternating current unit and select a transformer with the appropriate voltage boost or buck capability. Secondly, choose a location for the transformer that is as close as possible to the alternating current unit, while also providing adequate ventilation and protection from the elements. Thirdly, ensure that the wiring between the transformer and the alternating current unit is properly sized to handle the expected current load and minimize voltage drop. Fourthly, use appropriate connectors and fittings to make secure and reliable electrical connections. Fifthly, test the installation thoroughly to verify that the voltage is correct and that all connections are tight and secure. When deciding on the placement, remember that accessibility for maintenance is also a key factor to consider. While the transformer should be close to the alternating current unit to minimize voltage drop and power loss, it should also be located in a place where it can be easily accessed for inspection, maintenance, and repairs. Ensure that there is sufficient clearance around the transformer to allow for proper ventilation and to facilitate any necessary work. If the alternating current unit is located in a difficult-to-reach area, such as on a high roof or in a confined space, consider the logistics of transporting and installing the transformer in that location. In some cases, it may be more practical to install the transformer at a more accessible location, even if it means slightly increasing the wire length. In such situations, carefully calculate the voltage drop and power loss to ensure that they are within acceptable limits. Moreover, environmental factors play a significant role in determining the optimal location for the transformer. Protect the transformer from direct exposure to sunlight, rain, snow, and extreme temperatures. These conditions can degrade the transformer's insulation and reduce its lifespan. If the transformer must be installed outdoors, use a weatherproof enclosure to protect it from the elements. Ensure that the enclosure is properly ventilated to prevent overheating. If the alternating current unit is located in a corrosive environment, such as near the ocean or in an industrial area, take additional precautions to protect the transformer from corrosion. Use corrosion-resistant materials and coatings and regularly inspect the transformer for signs of corrosion. Furthermore, consider the noise generated by the transformer. Some transformers can produce a noticeable hum, which may be objectionable to occupants of the building. If noise is a concern, locate the transformer in an area where the noise will be minimized, such as in a mechanical room or a remote corner of the roof. Vibration can also be a concern, particularly if the transformer is mounted on a lightweight structure. Use vibration isolation pads or mounts to reduce the transmission of vibration to the building. You also want to make sure the transformer is installed in accordance with all applicable electrical codes and regulations. These codes and regulations are designed to ensure the safety of electrical installations and to prevent fires and other hazards. Consult with a qualified electrician to ensure that the transformer is installed in compliance with all applicable requirements. This may involve obtaining permits, conducting inspections, and following specific wiring and grounding procedures. Remember that electrical codes and regulations vary depending on the location, so it is important to consult with local authorities to determine the specific requirements in your area. Additionally, think about the long-term maintenance requirements of the transformer. Like any electrical equipment, transformers require periodic maintenance to ensure their reliable operation. This may include inspecting the transformer for damage, cleaning the windings, tightening connections, and testing the insulation resistance. Develop a maintenance schedule and keep records of all maintenance activities. This will help to identify any potential problems early on and to prevent unexpected failures. If you are not comfortable performing the maintenance yourself, hire a qualified electrician to do it for you. Proper maintenance will extend the lifespan of the transformer and ensure that it operates safely and efficiently. It is generally best to install the buck-boost transformer as close to the alternating current unit as possible. This will minimize voltage drop, power loss, and safety risks. Always consult with a qualified electrician for the best and safest installation strategy.